Every morning, 7 million people trust that trains will arrive within seconds of schedule, because if Tokyo Metro ever stopped, the world's largest metropolis would grind to a halt. A single hour's delay could freeze an entire city of 37 million. How does a system built for relentless movement survive on a knife edge between flawless flow and instant chaos? This is where the story begins. Tokyo's metro area is home to 37 million people, more than the entire population of Canada. Beneath the city's surface, a dense web of tunnels stretches for 195 kilometers, linking neighborhoods, business districts, and suburbs into a single living network. Every day, nearly 7 million riders, office workers, students, and families step onto Tokyo Metro trains. Their daily journeys add up to more than 2 billion trips each year, making this one of the busiest subway systems on Earth. The scale is staggering. Tokyo Metro alone operates 9 lines and 180 stations, but it is only one part of a much larger system. 18 different operators share tracks and coordinate schedules, weaving together over 1,000 kilometers of rail. At the heart of this network, stations like Shinjuku handle more than 3 million passengers a day, more than most airports see in a week. During the morning rush, trains arrive every 2 minutes or less, each packed to the doors. This system doesn't just move people, it keeps the city alive. If the train stopped, Tokyo's streets would jam with cars and buses within minutes. Essential workers would not reach hospitals or schools. Deliveries would halt. The city's pace depends on the relentless rhythm of the metro, a backbone that stretches from the crowded heart of Shibuya to the quiet edge of the suburbs. Without it, Tokyo would fall silent. Instead, millions trust it to run day after day with a precision that borders on the impossible. In 1927, Tokyo's first subway line ran just over 2 kilometers between Asakusa and Ueno. That single route, crowded with anticipation, formed the seed of a network that would eventually thread beneath the entire city. Over the decades, new lines branched out, stations multiplied, and connections deepened. By the 21st century, the system had grown into a dense lattice, with 9 metro lines, hundreds of stations, and seamless links to suburban railways. Animated maps of the city's rail arteries reveal a living organism, expanding and adapting with each era. Nowhere is this evolution more visible than at Shinjuku. Every day, more than 3.6 million people pass through its gates, making it the busiest railway node on Earth. During the morning peak, nearly 40% of all metro trips happen in just a few hours. Trains pulse through platforms in a tightly woven pattern, each arrival and departure measured in seconds. The scale is astonishing, but the real marvel lies in the system's fragility. Every train, every platform, every minute is part of a carefully balanced choreography. If a single point falters, if a train is even briefly delayed, the effect can ripple outward, throwing off the rhythm for thousands. A 1-hour stoppage would bring the city to a standstill, blocking streets, crowding buses, and stranding millions. In Tokyo, movement is not just a convenience. It is a necessity, and the entire city depends on the seamless flow of its metro. Keeping that flow unbroken is the system's most urgent challenge. Every train that enters Tokyo's tunnels is tracked and spaced by an invisible system of signals, sensors, and automated controls. At the heart of this system is a simple calculation. How many trains can safely run down the same track hour after hour without ever coming too close? The answer depends on headway, the gap in seconds between one train and the next. During the morning rush, that gap shrinks to just 110 seconds. That is enough to squeeze about 32.7 trains through a single direction every hour. If the gap widens by only 10 seconds, the capacity drops to 30 trains per hour. An 8% loss instantly felt by thousands of waiting passengers. Automation enforces this razor-thin margin. Continuous speed control systems monitor each train's position and speed, calculating the exact braking curve needed to keep a safe distance from the train ahead. If a driver accelerates too quickly or approaches a red signal, the system intervenes and applies the brakes automatically. With every train moving in lockstep, the margin for error nearly disappears. The entire network becomes a living equation where a 1-minute delay can ripple across the city. In Tokyo, precision is not a luxury. It is the only way to keep millions moving. Every second counts when a train pulls into a Tokyo metro station. The doors slide open, and a practice routine begins. Passengers waiting on the platform stand precisely behind painted lines, each queue aligned with the train's doors. As soon as the doors part, riders step aside, letting a stream of people exit first. Staff members in crisp uniforms watch for hesitation, signaling with gloved hands if anyone lingers. The entire sequence, doors open, passengers exit, new riders board, doors close, takes less than 30 seconds at peak times. This is urban precision. A typical dwell unfolds in 5 tightly measured beats. 5 seconds for the doors to open, 15 seconds for passengers to step off, 10 seconds for boarding, 5 seconds for the doors to close. This choreography repeats hundreds of times an hour across the network. On one side of a split screen, a station without markings or guidance shows passengers bunching at the doors, adding precious seconds. On the other, Tokyo's disciplined flow keeps the train moving on schedule. Micro-level order on the platform scales up to citywide reliability, turning seconds saved into millions of journeys delivered without delay. 7 of Tokyo Metro's 9 lines do not stop at the city's edge. Instead, they run straight onto tracks owned by suburban railways, passing seamlessly from one operator to another. This web links more than 1,000 kilometers of rail, connecting distant neighborhoods and satellite towns to the heart of Tokyo. 18 different companies coordinate schedules, share information, and synchronize train movements, all to keep the flow unbroken. Through running agreements mean a commuter from Saitama or Chiba can board a train far outside the city and ride directly to a job in central Tokyo. With no transfer required, the benefits are clear: fewer crowded interchanges, smoother journeys, and a system that spreads demand across the entire region. But this tight integration comes with a cost. If a delay happens on a suburban line, the disruption can spread quickly, rippling through the metro's core and affecting trains dozens of kilometers away. The more closely these networks are tied together, the more they depend on each other's precision. Inside Tokyo Metro's Operations Control Center, every train's movement is tracked in real time. When a delay threatens to ripple through the network, controllers act within seconds. If a train is held up by a crowded platform or a mechanical check, the system doesn't just wait for it to recover. Instead, controllers use a tactic called delay absorption. They might hold the next few trains for 20 to 60 seconds each, spacing out departures to smooth the flow and prevent bunching. This approach spreads the impact of a single delay across several trains, turning a potential bottleneck into a barely noticeable pause for thousands of riders. The payoff is visible in the numbers. 99.8% of Tokyo Metro trains arrive on time, and the average delay is less than 1 minute. Even during the morning crush, the system bends but doesn't break, adapting moment by moment to keep millions moving. As the last trains leave the platforms around midnight, a second shift quietly takes over beneath the city. Maintenance crews step onto the tracks at 12:30 a.m., working through the darkness until the first morning trains are ready to roll at 4:30 a.m. Their task is relentless. They inspect rails for hairline cracks, check every signal, and replace worn components before they fail. This nightly routine is not just repair, it is prevention built into the system from the start. Over decades, each new layer has been added without ever stopping the trains. Signaling upgrades in the 1960s, platform improvements in the 1980s, and through running agreements in the 2000s were integrated while service continued. Archival images trace this slow accumulation, from the first tunnel diggers in 1927 to the rollout of automatic controls, to the rise of seamless connections across the region. What holds Tokyo Metro together is not a single breakthrough, but a scaffold of careful refinements, each one supporting the next. Remove even one layer, and the balance could collapse. Every day, Tokyo's precision keeps millions moving, proof that true reliability is not an accident, but the result of relentless, layered design. As cities worldwide face rising density, the quiet choreography beneath Tokyo streets offers a blueprint and a challenge. Efficiency at this scale is always a choice. Thanks for watching.